Circles is quite a difficult Core 1 topic. We're going to have a look at circle equations, different ways of writing the equation of a circle, and learning from the equation the coordinates of the centre of the circle, the length of the radius, and the coordinate axes intercepts. We're going to start off with a nice easy circle, centred at the origin with a radius of 1, a unit circle. We're going to let xy be any point on the circle, so we've just randomly placed a point here, but this could be any x and y value that's on the circle. And if we now consider the length x and the length y, and the fact that we have a right angle here, then if we use the triangle OPM, we can see by Pythagoras' theorem that the sum of the squares of the two smaller sides equals the hypotenuse squared. So we get x squared plus y squared equals 1. This equation, x squared plus y squared equals 1, that we've got from Pythagoras' theorem, is an equation that ties together the x and y ordinates on the circle. So any point on the circle satisfies that equation. We can see that the point 1, 0 will be on the circle, for example, because 1 squared plus 0 squared equals 1. So the point 1, 0 is proved to be on the circle by placing the x value and the y value into this equation and getting the answer, the right hand side of 1. If we try the point 0.5, 0.5, we can see that that doesn't lie on the circle, because if we square 0.5, we get 0.25, and 0.25 plus 0.25 gives us 0.5. So that doesn't equal 1. In other words, by putting in 0.5 for x and 0.5 for y, we get 0.5 and not 1. Therefore, that point isn't on the circle. So that equation then has to be satisfied by any pair of coordinates, x and y values. If we square them, add them together, it's got to give us 1 for that particular circle. We're now going to have a look at a more general equation for circles centred at the origin. Rather than using 1, we're now going to call this distance r, which is appropriate, isn't it, because it's the radius of the circle. And we can now see that using Pythagoras' theorem again, we get x squared plus y squared equals r squared. And this gives us a general equation for any circle that's centred at the origin. What happens though if the circle isn't centred at the origin? Say the centre of the circle is the point AB. So we can see here we've got a circle not centred at the origin but centred at AB. Again, we'll pick a random point on the circle P. And again, if we use Pythagoras' theorem, we can still work out an equation. This distance here is x, which is the whole of this distance here, isn't it, from here to here, minus the distance a. So this distance is x minus a. This distance here, well, this distance, all of this distance is y, as we can see here. So this will be y minus the y ordinate there, b. So using Pythagoras, we get x minus a squared, the length of that side squared, plus y minus b squared, the length of this side squared, equals the radius squared. Have a good look at this and try and make sure that you understand what's going on. Another way of thinking about this equation that we've just derived is how the circle translates. If we start with the centre at the origin, the translation from here to here can be represented by a translation in the positive x direction of A and in the positive y direction of B. And we can replace x by x minus A and y by y minus B. Again, giving us that equation. If you're not sure how this works, try it with some numbers and logic out for yourself why it works. Just do the x translation first and think, well, how am I going to get a y value of 0? Or just do the y translation first and work out, well, how am I going to get an x value of 0? So to summarise, the equation of a circle with centre AB and radius r is x minus a all squared plus y minus b all squared equals r squared. This is the preferred form of the equation. It tells us a lot of information. It tells us the centre. It tells us the length of the radius. So this is the preferred way that we would leave the equation. It would be unusual to multiply out the brackets. So for example, if we've got a circle with a centre 4 minus 3 and a radius of 5, we can find its equation by using this formula. And then to find out if the point 21 lies on, inside or outside the circle, we would test that point and see if it agrees with the radius of 5. Well, to start off with, if the centre's 4 minus 3, we get x minus a, so x minus 4, y minus b, which is y minus minus 3, so we get x minus 4 squared plus y plus 3 squared equals the radius squared, 25. Trying the coordinates in the equation, we put 2 in for x and 1 in for y, we get 20, which is clearly smaller than 25. And because it's less than 25, that means the point lies inside the circle. The distance of the point from the centre is less than the radius, so the point lies inside the circle. If it was bigger than the radius, it would be outside. If it was the same as the radius, it would be on the circle. It would satisfy the equation. So to summarise, the equation of a circle with centre AB and radius r is that. To determine whether a point lies on, inside or outside a circle, substitute the coordinates of the point into the left-hand side of the equation and compare the answer with r squared, with the radius squared. Okay, your turn. Have a go at these. If you're successful with these, then you'll be ready for the lesson. Take your time. Perhaps go back over the video if you've not fully understood it. It is a difficult topic. The whole idea of these videos is so you can go through them at your own pace. Okay, here's the answers. So remember, the equation is x minus a all squared plus y minus b all squared equals r squared. So we're going to put those values in. So we put minus 1 in here for a. So we get minus minus 1, which gives us x plus 1. And then 2 in for y, y minus 2 all squared, and the radius is 3, so we get 3 squared 9 there. It then asks us to multiply out the brackets, so if we multiply out these brackets we end up with this, and then simplify, gather the like terms, so gather the numbers together, bring the 9 over here, and we end up with this. So that gives us 2 as P and minus 4 for Q. To find out whether this point lies on, inside or outside this circle, we substitute in the x and the y ordinates into here. So 3 for x, minus 5 for y. Multiply out, we get 1 squared, we get minus 2 squared, so 1 plus 4 gives us 5, which is greater than the radius squared 4, so it's outside the circle.